at Lautech Academy, and I'll be taking mathematics. And the topic we'll be considering is calculus, differential calculus to be precise. And as we know that calculus is the study of the rate of change of a function, while differential calculus is the study of the rate of change of a variable with respect to another variable. And considering the function y equals a of x. Now our y is dependent on x, so we have the dependent variable, which is the y, and our x is the independent variable. So y is also called the outcome variable, because by solving with respect to x, you get the value of the y. So under differential calculus, there are some things that we'll be checking. And the first one is there are some basic functions and their derivatives that we're supposed to know. They will help us through our calculation as we go along. And we have the rules of differentiation, which are the addition rule, product rule, quotient rule, the chain rule, which is also called the function of a function. Then we have the differentiation of natural logarithm and inverse trigonometric functions. And we have the applications of differentiation. The end point of calculus is to actually apply it in our everyday or day-to-day life. So we have a number of places in which we can apply our differentiation or differential calculus, and we'll be checking all of those. So now we are going to be checking the basic functions and derivative of differential calculus. Now we are differentiating a constant with respect to x or with respect to another variable. We have 0. The resultant is 0. Any constant that we are differentiating will give us 0. And if we are differentiating a constant with the variable x, we have the constant. So basically, these are the basic functions and their derivatives that we are supposed to know, because they will be helping us along as we go along in the video or as we are solving our questions. Now we want to check the rules of differentiation, and the first one is the addition rule. Now checking the rules of differentiation that we're talking about. Now we are checking the first rule, which is the addition rule. Now we are going to check some examples to for us to know what the addition rule is all about in differential calculus. Now the first example says that find the derivative of y equals to 4x cubed plus ln x. Now these functions are added together, and so we can use the addition rule in finding out what the question is talking about. Now 4x cubed. Now we can go back to our basic functions and their derivative to check what to do. Now in this the third line, we have x raised power n, and we can see what was done. The power of x was brought down, and one was subtracted from it. So that's what we are going to do for this particular one. Then for ln x, we know that when we differentiate our ln x, whatever we differentiate ln anything, that the derivative will be 1 over that thing. So now let's see what we are doing. So y equals to, like I said, 4 multiplied by the power of x, which is 3, then x, which is the dy dx equals 4 multiplied by 3, then our variable x raised to power 3 minus 1, like I said, plus the derivative of ln x, which is 1 over x. Now dy dx equals 12x raised to power 2 plus 1 over x. So that's the derivative of y with respect to x. The second one, it says if y equals x raised power x squared if y equals to x cubed minus 11x squared minus 30x plus 4, then find what value of x is if dy dx equals 10. So dy dx equals 8 times 3 dot x raised power 3 minus 1 minus 11 times 2 x raised power 2 minus 1 minus 30 times 1 dot x raised power 1 minus 1. Then remember that when we differentiate the constant, the derivative is what? 0. So the 4 is going. Now dy dx equals 24x squared minus 22x minus 30. Now we are told that we should find the value of x if dy dx is equals to 10. So that means we have to go further in this particular question. So dy dx, which is equals 10, equals 24x squared minus 22x minus 30. Then we have 24x squared minus 22x squared minus 22x minus 30 equals 10. Now we can divide through both sides by 2 since 2 is common. So dividing both sides by 2, we have 12x squared minus 11x minus 15 equals 5. Then bringing 5 to the other side, we have 12x squared minus 11x minus 15 plus 5 equals 0. 12x squared minus 11x minus 10 equals 0. Now we can use our quadratic formula, but whichever one, the substitution method, whatever method that is suitable to find the value of x. Oh, 5 coming to this side should take a negative sign. So this should be minus 15 minus 5. Then we should have minus 20. Then you can use any quadratic formula or method that is appropriate for solving that particular quadratic equation. Now for the third example, we have to find the derivative of y equals x squared minus 2x plus 1 divided by x squared with respect to x. Now the y dx equals, now to the third example, we have to find the derivative of y equals x squared minus 2x plus 1 divided by x squared. Now you can divide through by x squared. Y equals x squared over x squared minus 2x over x squared plus 1 over x squared. Then x squared cancels out, then x cancels 1 of the x here, and we have y equals 1 minus 2 over x plus 1 over x squared. Now we can also write this as y equals x raised power minus 2 minus 2x raised power minus 1 plus 1. So I rewrote this as this now. To find the derivative of y, we have dy dx equals x raised to power minus 2 x raised to power minus 1 plus 1. Now we have minus 2x minus 2 plus 1 minus 1 rather minus 2 multiplied by minus 1 x raised to power minus 1. Then when we differentiate a constant, we have 0. dy dx equals minus 2 x raised to power minus 3, then plus 2 x raised to power minus 2, which can also be written as minus 2 over x raised to power 3 plus 2 over x raised to power 2. Now, still under the rules of differentiation, we've talked about the addition and we've seen various examples on that. Now, moving on to the product rule. Now, when we have variables that are multiplying each other, there are ways in which we can solve that particular question or that kind of problem. So when we have now for the product rule, we have a formula that we use for the product rule, and that formula is what we call the product rule. Then we have u dv dx plus v du dx, where u is the, okay, for example, so that we can see what we are talking about. When y equals root x into brackets 1 plus 2x raised to power 2. Now, our first variable will be our u. So my root x is our u, and the second variable, which is 1 plus 2x, okay, will be v. Then we can now use this formula to solve this particular question. Then we have dy dx equals, now what's our u? We have root x, and our dv dx. Now we are differentiating our v, which is 1 plus, our v equals 1 plus 2x, everything squared, and our u equals root x, or x raised to power half. Now we want to differentiate our v with respect to x. So when we have 1 plus 2x, everything raised to power 2, then differentiating that, we have our 2 first. We have to differentiate everything in the bracket first. We have to first talk about the whole bracket before we differentiate what is inside the bracket. So now this 2 has to come down. We have 2. Then differentiating what is in the bracket, our 1 is a constant, so that's 0. But now when we differentiate 2x, we have what? 2. So dot 2. Now we can now continue or finish what we are doing. So first of all, we brought this 2 down, then we differentiated what is inside the brackets, which is 2x, which is 2. Then we now differentiate the whole variable, which is 1 plus 2x, 2 minus 1, plus, what's our v? Everything representing our v is what? 1 plus 2x all squared, multiplied by du dx. That is, we are differentiating our u with respect to x. Our u is x raised to power 1 over 2. So we have 1 over 2 x raised to power minus half. That is 1 minus or that is half minus 1. So we have dy dx equals x raised to power half into 4, 1 plus 2x, then plus 1 over 2x raised to power minus half into 1 plus 2x all squared. You can still simplify this further. So that's the first example on our product rule. So in the next video, we'll take one more example on our product rule, then we'll move on to the quotient rule. Okay.